So along with all this probability, we also have geometric probability, which means that we're going to be working with shapes then and find the probability of something happening using shapes, using ratios, lengths, areas, and volumes. So here we have a figure. We have a square that has a triangle inside it and then a rectangle inside that triangle. And the question is, if a point inside the figure is chosen at random, what is the probability that the point is inside the shaded region? So we're still going to be working with our finding our favorable outcomes and our total outcomes. So still in our denominator, we want what's the total. In other words, when we're talking about total, when we're talking about a geometric figure, we're talking about the area of the whole thing then in this case. Okay? And when we're talking about favorable, then we're talking about just the area of the shaded portion. So shaded area over the total area is what's going to give us that probability. Okay. So once again, we've been doing the total first, so let's stay with that process. What's the total area in this case? It's 9 squared, right? Okay, we have a big square that's 9 by 9, so it's 81. Now, we need to find the area of the shaded portion. So we have a triangle there that's had a rectangle removed from it. Okay. So how do we find the area of a triangle? The area of a triangle is 1/2 base times height. Okay. And the base in this case is 9. The height is 9. So this is 1/2 9 times 9. And then we have to subtract the area of this rectangle, which is 3 by 4. So 81, half of 81 is 40.5, right? And 40.5 minus 12 would be 28.5 over 81. Now, can I leave that answer like that? Can I leave a decimal and a fraction? And the answer is no, you can't leave a decimal and a fraction. That's why you have that wonderful piece of technology which will rewrite the fraction for you if you need to. So we've got 28.5 divided by 81, which is 0.35185185119. But if I go math, fraction, I can convert that back to a fraction, which is 19 over 54. And so that would be the area, or the probability that a point lands inside the shaded area is 19/54. And all it is the ratio, the area of the shaded portion, over the area of the whole thing. Okay, experimental probability is found when we've actually conducted an experiment and we find probabilities from the results of that experiment. So when we say that the probability that we if we flip a coin 50 times, we would expect we would get 25 heads and 25 tails, right? But if I actually did the experiment, I may end up with 30 and 20 instead. And so lots of times we'll use experimental probability to find our results instead of just doing what we expect is going to happen with theoretical. But if you notice here, the formula for experimental probability is actually similar to the one for theoretical. Still, the number of times the event occurs, which would be favorable outcomes in the numerator, over the number of trials, which would be the total number of outcomes. So we're basically just using the same exact formula, but written in using different terminology. So this might actually be the easiest part of this because of that reason. So it says the table shows the results of a spinner experiment. Find each experimental probability. So they actually spun the spinner. And how many times did they spin it is the first thing we need to find out. So what was the total number of spins? And there was 50. Okay. All right. And when you're counting like that, you always want to put numbers together that connect. So 11 and 19 make 30, 6 and 14 make 20. So that would give us a total of 50. So what is the probability of spinning a 4? Well, it happened 14 times out of the 50 spins. So 7 out of 25. Okay, so letter B says spinning a number greater than 2. Does that include 2? No, because 2 is not greater than 2, is it? Okay, so if we're talking about greater than a specific number, that means everything larger than that number. So in this case, we're only counting the 3s and the 4s. So that would be 33 out of 50. 19 plus 14 is 33 out of 50. So experimental probability, you're just going to have results from a table, and then you're going to find your answer from those results.